Hello, my name is Matthew Foote, and this is my Project 10 presentation for Software Development for Real-Time Embedded Systems course. In this project, I'll be working with a quadcopter, recording roll, pitch, and yaw information, latitude, longitude, and altitude information, and recording video from a Raspberry Pi on my quadcopter that will be sent over Wi-Fi to my host machine. In my final configuration, I have my quadcopter with a Raspberry Pi and Arduino attached to the top. The Raspberry Pi, you can see, has 3 USB ports plugged into it. Those include the Arduino for power, the webcam, and the GPS mouse. On the right, you can see that there's these cables between the Arduino and Raspberry Pi for the I2C interface. And on the left, you see cables from the Arduino to the IMU device over I2C. So this is my configuration. First code we'll be talking about is getting the IMU information over the I2C interface. So on the Raspberry Pi, we use Python code on the left as a master to read data from the I2C bus. And then we simply print it out while also recording it to a file. On the right, we set up an Arduino script that sets up the BN055 device and then records the events as we did before, but this time we send it over I2C in the form of a byte array. So here's an example of the code running while I am flying my copter. You will see the footage later, but as you can see, this is coming from Python on the Raspberry Pi using this script. So you can see the data moving as I continue to fly around. Next, we have the short script for the GPS information that's over USB. So we collect that using this small Python script that we run, and it stores all the latitude, longitude, and altitude to a file. So in this case, what we've done is we just finished a run, as you can see with a keyboard interrupt, and I've recorded the data in the form of a file. So we go to data_gps.txt, and you can see that periodically we store latitude, longitude, and altitude information based on the location of the quadcopter. Last thing we were supposed to do is show video. So here's an example of me flying around my living room from the standpoint of my computer. You can see the video on the left updating. It is off of port 8081 on the Wi-Fi connection. And you can see on the right that the pitch, raw, and roll information. Now here is just a video of me with a configuration of my quadcopter flying. This is from the other standpoint. In this case, the Arduino is actually connected to the bottom. After a couple trials, it was moved to the top when it kept falling off. So this is the data that it was recorded for. And that is my presentation for Project 10. Thank you.